Hello and welcome to this new installment of Building Public Chess Game. In this episode we are going to program the movement of the rook, the bishop and the queen. Those pieces share common movements, so we are going to accommodate the code in order to not repeat too much. So we are going to start with the rook. So let me create a new class file in the pieces directory and its spec file as well. We are going to copy here the specs. And now we can start to write the rook class. Don't forget to put the new class in the pieces constant in the main file. Just here. And if we run the tests, we are getting an error because we don't provide any directions method. Let me create an empty one just to pass the tests. And also I'm going to create an empty value method here. So if we run the tests again, we get all the pending tests that we have to implement. So let's start by the first spec. In an empty board like this, the rook should move up, right, down and left. So the positions that we should get are 2-3, 1-3, 0-3, 3-4, 3-5, 3-6, 3-7, 4-3, 5-3, 6-3, 7-3, 3-2, 3-1, 3-0, and if we compute the relative positions, those will be -1, 0, -2, 0, -3, 0, -4, 0, -5, 0, -6, 0, -7, 0. This would be the up movement. Now let's go for 0-1, 0-2, 0-3, 0-4, 0-5, 0-6 and 0-7. This is going to be the right movement. 1-0, 2-0, 3-0, 4-0, 5-0, 6-0 and 7-0. This is going to be the down movement, and the last one 0-1, 0-2, 0-3, 0-4, 0-5, 0-6 and 0-7. This is going to be the left movement. Alright, we're gonna start to implement the test. Let me copy the expected target positions here. Okay, and for each of the expected position, we are going to check if if it's contained in the returning possible movements, like in the other test. So let me write the spec here. It should move to expected. Okay, rook possible moves for the given board should contain the expected movement. Okay, let's go to run the tests, and we get an error here because we didn't implement the directions method. So go back to the rook class and let me copy the relative movements here. And if we run the tests again, now we're passing. Okay, so we are going to check the case in which the rook is surrounded by pieces of the same color. Since the rook cannot jump, we should get an empty array. So let's go to implement here. Rook, possible moves for the given board should be empty. Let's run the tests. And we have another error. We got a lot of positions that could not be possible, so this is going to be an error in the possible moves method. So let's check the piece class. And we are going to break the loop here just after find an invalid movement. Let's check what happens. And now it's fixed. Okay, let's back to the next test. Now the rook is surrounded by pieces of different colors, and according to the movement rules, we can't move to any position, so the returning array should be empty. Run the tests, and everything is working. Let's move to the next one. We are on this board, and rook could move to this position, capture the pawn, move to the right, capture the bishop, and that's it. Let's write down the possible movements. 2-4, 2-5, 2-6, 2-7, 1-3 to capture the pawn, 3-3, 3 4-3, 5-3, and 8 in total. Possible moves for the given board should have a size of 8. Let's run the tests, and we get another error. We got 11 movements instead of 8. Probably we have another error in the possible moves method. We are going to break when we reach to a position that it's not empty. Let me put a comment here just to clarify things. If we reach a position that it's not empty, that means that there is a piece in there, so we have to break in order to not jump over that piece. Let's run the tests, and we have a failure because we don't have implemented the empty method on the board class. So we are going to move to the board class for a moment, implement the functionality, the empty method, and go back to our possible moves algorithm. I'm going to create an empty method here that should return a Boolean if the given position contains a piece or not, depending on that. Okay, so I have to get the given position, and I have to check if the given position is nil or not. If we run the tests, now are working as expected. So let me create a couple of tests for the new method. We are on the board spec file. I'm going to create a new scenario with the describe for the empty method. And we are going to create two pending tests just to check if a given position it holds a piece or not. Should return true if the position is empty, and the other way around, should return false if the position is not empty. So for the first one, I'm going to create an empty board. and I'm going to check if, for example, if the position 0, 0, it's empty. 0, 0, it's empty, should be true, because we have an empty port. Okay, run the tests, and it's passing. Okay, no, it's not passing. What happens? Okay, I forgot to put an it instead of a pending, so now it's working. Okay, let's go. Let's copy here the same code, and we are going to implement that test. Instead of an empty board, we are going to create a random piece with the piece factory, and we are going to create a board with the piece in the middle, with the factory as well. And we are going to check that the position 3, 3, that it's occupied by the piece, should return false. Okay, it's working. So now we can go back to our Rook spec and continue with the next spec. A Rook should have a value of 5. So Rook, let's create for example, a weight Rook. Rook dot value should equal to 5. If we run the tests, we get an error because we didn't implement the method itself. Let's put a 5 here, run the tests again, and now are passing. Okay. And with that, we are finished with the Rook. Let's go now for the bishop piece. We're going to create an empty bishop class here. Class chess bishop inherits from the piece. And now we are going to create the spec file. Okay, require the helper, the spec helper. Let me copy the tests. Now we are going to pass the tests. Okay, let me create the two abstract methods here. Directions. And the value. Let's run the tests, and we can see all the pending specs. Finally, we add the new class into the pieces constant here in the main file, bishop, and we are ready to start with the first spec. A bishop can move in diagonal directions, so let me write down the positions here. 2, 4, 1, 5, 0, 6, 4, 4, 5, 6, 5, 5, 6, 6, 7, 7, 4, 2, 5, 1, 6, 0, 2, 2, 1, 1, 0, 0, and let's compute the relative moves. We are going to start with 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and 7, 7. This is going to be the up right diagonal. 1 minus 1, 2 minus 2, 3 minus 3, 4 -4, 5, -5, 6, -6, and 7, -7. This is going to be the down right direction. Let's go with -1, -1, -2, -2, -3, -3, -4, -4, -5, -5, -6, -6, -7, -7, and this is going to be the down left part. -1, 1, -2, 2, -3, 3, -4, 4, -5, 5, -6, 6, -7, 7. This is going to be the last one, that it's the up left diagonal. Okay, let's go to the expected target positions, and let me copy here the values. And we are going to check if the possible moves method contains each of the target positions. So the same as always, it should move to bishop. Possible moves with a given board should contain the expected position. So let's run the tests, and it's failing because we don't have anything here in this method, so we are going to copy the values here. We run the tests again and it's working. Let's go for the next test. When the bishop is surrounded by pieces of the same color, we can't move the bishop at all, so we are going to implement the test. Bishop, possible moves for the given board should be empty. Run the tests, and it's are passing. Okay, now let's go for this scenario. The bishop is surrounded by pieces of different colors. We have two movements, so we are going to create the test as before. Bishop, possible moves for the given board. The size of the possible moves should be 2. Okay, we run the test and everything is okay. Now we have the board with the different possible movements, so we can move here, here, here. We can capture the queen, so 10 movements in total. Bishop, possible moves. The size should equal 10. Okay, pass the tests and they are passing. Okay, so the last spec, bishop value should be 3. Okay, bishop, we are going to create a new one. Bishop value should equal 3. Run the tests, and they are failing. We go to the value method here and we put a 3 and run the tests again, and now we're passing. Okay, we are done with the bishop. It's time to implement the queen piece. We are going to create a new file for the queen class, and then a queen spec file as well. Okay, let me require the spec helper here and copy the specs. And we are going to create an empty class. and we are going to add class into the main file here. And we are going back to the Queen class, and we are going to create the empty abstract methods, directions, and a value. So if we run the tests, okay, nothing happens. Should be an error because the pending specs are missing. Okay, I put the wrong name in the spec file, so let me fix it. The spec file should be queen queen-spec, and there is an error here as well. We have to comment. Okay, and those are the new specs. So we can start with the first one. A queen in an empty board moves in the same directions of a queen and a rook. So here, here, and here. Here as well. So let me copy the expected targets from rook and bishop here. And we are going to implement the test itself as before. So for each expected target position, we are going to test that the possible moves in the given board should contain the expected target. So we have to put here and queen, possible moves for the given board should contain the expected value. Okay, we are going to run the tests, and they are going to fail because nothing is implemented in the directions method. So here, instead of copying the relative moves as we did before, we are going to create those constants that will be shared between queen, rook, and bishop. I'm going to create a constant for up, right, that is going to be the right diagonal, right, down, right, down, down, left, left, and up, left. Okay. So now we are going to the piece class, and we are going to copy here all the constants with the values copied from rook and bishop. And now we are going to refactor the rook and bishop classes in order to use the constants. So we are going to start by the rook one. We are going to remove all the numbers here, and we are going to replace it with the constants. So for a rook, it should be relative moves right, left, up and down, up and down. Okay, we are going to run the tests in order to check that everything is working, and it is. So now we are going for the bishop class. We are going to remove those numbers and replace it for the constants. Relative moves up, right, down, right, up, left, and down, left. Okay, we run the tests again, and everything is passing. So we are going back to the specs, and we have this scenario here. We cannot move the queen at all. So let's write the test. Queen, run the tests again, and everything is passing. So let's go for the next one. The queen is surrounded by pieces of different colors. We can capture these two pieces, 1, 2, and 1, 4. So let's back to the test. It should capture 2 pieces. So the possible moves should equal 2. Let's run the tests. Okay, they are passing. And now we are going with the last scenario, this here. We can move here, capture the pawn, move here, 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 capture the bishop, here, and that's it. So we have 1, 1, 2, 4, 4, 3, and 3. That's it. 18 movements in total. So let's implement it. Queen, possible moves with the given board. Size should equal to 18. Okay, let's pass the tests. And everything is okay. So we are going with the last one. Queen is the most valuable piece in chess with a value of 9. So we are going to test the value here. Value should equal 9. Let's run the tests, and they are failing because we didn't implement anything in the value method. So we go here and put a 9 and run the tests again, and everything is okay. Okay, that's all for today. In the next video we are going to finish the pieces with the pawn movement, that it's the most complex movement in chess. So see you in the next episode. Bye.